Everybody, it's me, Monsieur, and we are going to begin the review. I said I would record it, so here it is. We're going to start off with finding counterexamples and false positives, or just figure out if the statement is true or false. Starting off, I have if n is equal to 1, I have n cubed is equal to 1. That's a counterexample, so we call this F. Okay. The next one, if I have an angle with y and the sides are congruent, then this is also false. Okay? And y is the midpoint. Here I have two planes intersect, and their interpoint is a segment. It could also be a line when two planes intersect. Okay? And so that is also false. This is true. I end up with a line segment with A and B. Over here, two lines intersect, and their intersection is a point. That is true. There's no counter example, and we have two planes intersecting over here. And the line of intersection is part of both, so this is also true. Now we're going to talk about converse, inverse, contrapositive. So for the converse, we want to switch places, and we want to say if the angle is acute, then its measurement is less than 90. Okay? And that is true. The inverse, we want to take the statement and negate it. So if the measurement of the angle is not less than 90, then the angle is acute. And that is also true. And last, for the contrapositive, we want to take the converse, and we want it to be true. So the contrapositive, if the angle is not acute, then its measurement, if the angle is not acute, then its measurement is not less than 90. If the angle is not acute, then the measurement is not less than 90 degrees, and that's also true. I am going to post the answers for the next two, but it uses the same system that we used here, okay? The same definitions. Okay. We're now going to write a biconditional statement. A biconditional statement is a statement that has if and only if, and we call that IFF. Okay? And we want to write an if-then statement. All Grosse Pointe South students take 3 math classes. So I'm going to say, if you are a Grosse Pointe South student, then you take 3 math classes. Okay? The biconditional statement would be you are a student at Grosse Pointe School if and only if you take 3 math classes. Okay. Now we want AC perpendicular to, let's look at 14, 15, and 16. It uses this drawing. And is AC perpendicular to BC? I'm going to say yes, because we see the little corner. Now we have ACD, and DCB. They are perpendicular because angle, are they complementary? And that's the definition of perpendicular or complementary. So angle CACD plus angle DCB is equal to 90. So I'm going to say yes. So when you add them up, they equal 90. And does CD bisect ACB? I'm going to say no, because x does not equal to 2x. Okay, x degrees does not equal to 2x degrees, and so the answer is no. Okay, we're going to move on to law of detachment and law of syllogism. Law of detachment, just to make sure we have it right, is if P, then Q, P, therefore the conclusion is Q. Law of syllogism, okay, I like to write it small. It takes 2 ifs. If P, then Q. If Q, then R. Therefore, if P, then R. So we want one piece of information that is repeated, and that's going to be Q, and we need 2 ifs. So let's start off with the first one. I only have 1 if, so it's law of detachment. And I'm going to label it. It is a weekday, P. Natalie's in school, that's Q. And P, today is Wednesday, it's a weekday. And our conclusion is Q. Natalie is at school. Okay. The next one, if you like to study history, then you like to read books. If you like to read books, then you like going to the library. So I have 2 ifs. And now we're going to look for our P's and our Q's. So this is P, that's Q, this is Q. Okay, we're both reading books, and that's R. So our conclusion is P goes to R. So if you like to read history, okay, if you like to read history, then you enjoy going to the library. Okay, and that is law of syllogism. Okay, number 19, if you can drive a car, then you must act responsibly. If you pass a driver's test, then you can drive a car. So this is not so straightforward, which one is P and which one is Q and which one is R. So I'm going to say that the sentences have been replaced because driving a car appears twice, and that has to be our Q. So I'm going to say this is P, that's Q, this is Q, you could drive a car, and this is R. And now I have to write, if you pass a driver's test, then you must act responsibly. Okay, and that, of course, is the law of syllogism. 20 and 21 is going to be on the answer key, and you could look at it later. Let's look at 22. Okay. I have the addition, segment addition postulate. I'm just going to write out the drawing, A, B, C. So I'm going to say AB plus BC is equal to AC. Oops, there you go. And now we're going to use that to answer 23. I have NV, in between it is A. And I see that I have AV is 16, and A is 4x, and V is 6x minus 2. So I'm going to write here 6x minus 2 is up here. I have 16 and 4x. So I have 6x minus 2 is equal to 4x plus 16. Okay. When I solve it, I end up with x is equal to 9. Let me see, 2x minus 2 is equal to 16. I'm going to add 2 to both sides. I'm going to end up with 2x is equal to 18, and x is equal to 9. Okay. Let's look at the next one. Steps and reasons. I'm going to do 24 and 25, and you could look at 24 on the solution sheet. So this start off with what's given. 7x minus 2y is equal to 20. This is given. I'm going to subtract 7x from both sides. And I'm going to get negative 2y is equal to 20 minus 7x. Next, I'm going to divide both sides by negative 2. That's division. And I end up with y is equal to and that is all you need to do to solve for y. Let's do this one. Very similar. I have 3y plus 8 is equal to negative 4y minus 34, and that's given. I'm going to add 4y to both sides. So I end up with 7y plus 8 is equal to 4y negative 34. Now I'm going to use subtraction. I'm going to, sorry, this I already got rid of. I'm going to subtract 8 from both sides. And I end up with 7y is equal to negative 42. My last step is division. I'm going to divide both sides by 7. And we get y is equal to negative 6. Oops, I didn't have to circle it. That wasn't an answer. This one will be on your sheet. Let's look at reflexive. Let's go over the definitions. Reflexive is same side or angle. Transitive, they equal the same thing, so they equal each other. So this is I mean angles or segments. Okay. So for here I have AB is equal to XY. CD is equal to XY. So now I have then, if, then, So I have AB is equal to CD. Symmetric means they could switch places. So AB is equal to CD, then CD is equal to AB. And I'm just going to do congruent because with numbers it's a little more straightforward. You don't use symmetric when you have numbers so much. And substitution, of course, if AB is equal to 7 and AB is equal to CD, AB is equal to CD, then CD is equal to 7. So you're just substituting it in. Okay. Let's look at 27, 28, 29, and 30. If angle 1 is equal to angle 3, then measure of angle 3 is equal to angle 1. Here, this is transitive. Up here, AB is equal to CD, then CD is equal to TU. And you don't have to know that it's transitive. And this is symmetric, but it's helpful. Here, we're adding the same thing to both, and that's the additive property. So this could be RS, and this is WX. Over here, I have 3 times 45, and we're going to call this substitution. Okay, that's exactly what it is. Name the property illustrated by the statement. So this is reflexive, the first one, and that means angle ABC is congruent to angle CBA. This is symmetric, and this is transitive. Okay, and it's equal to S. Let's go over this one. Although I did it in class, I have everything is based on reading these two. ER is congruent to LV, LV, and ER, so I have a 90-degree angle. The next one, it says OM is perpendicular to TG, OM and TG, and this is perpendicular. Okay. And the last piece of information is angle GOE is 47, GOE 47. And now we could start figuring this out. If this is 47 and this is 90, that means I know this is 90 and this is 43. These two are vertical, so I'm going to write 43 and 47. Once I have 43 over here, I know that it's 90 for these two angles. So I'm going to write 47 over here. And this is 43 because these two add up to 90, and that's 43. Let's write in our answers. I have, this is 90, this is 90, this is 43, 43, 47, 137, 43, and 137. Okay, there we go. Let's do the next one. Okay. Write a proof of the following: RT and SU, RT and SU. That's given. RT is equal to SU. That's given. RS plus ST. So we're going to take this and we're going to split it up into two parts. Okay, so RT is RS plus ST, and that's That's segment addition. RS plus ST is equal to RT. That's segment addition. And I'm going to do the same over here. ST and TU is equal to SU. ST plus TU is equal to SU. That's segment addition. Now I'm going to do substitution. Okay. Because substitution because STTU, because I have RT equaling SU over here, okay, or transitive, you could have them equal each other. So I'm going to go ST plus TU is equal to RS plus ST. And now I could do subtraction. I'm going to subtract ST, and I'm going to get TU is equal to RS. And that is what we wanted to prove. Let's do the next proof. It is very similar. We did this in 1, 2, 3, 1, 2, 3, 4, 5 steps. Okay, let's do this proof. AB is equal to CD, AB is equal to CD, AB and CD. This is given. Okay. Now I'm going to go over here. If you add the same thing to both sides, the equality is kept. So I'm going to go AB plus BC is equal to AC. And now I'm going to go is equal to AC. This is segment addition. Okay, and I'm going to go BC plus CD is equal to BD. That's segment addition. Okay, all we did was add the same thing to both sides. And now we're going to do substitution. We're going to take AB and we're going to bring it into CD over here. So we have BC plus AB is equal to BD. And now we have, they're equal to the same thing, so we could do transitive. Okay. So I'm going to do transitive. So now I have AC is equal to BD. Okay. So I have 2 more proofs left. I'm going to try to do them quickly. Okay, our statement. Angle 3 is congruent to angle 2, given. Okay. And now we have a vertical angle. Angle 2 is congruent to angle 6. It's vertical. And then angle, whoops, not 2 is, 2 is congruent to angle 6 because they're vertical angles. And now we have a transitive property. So I'm going to say angle 2 is congruent, angle 3 is congruent to angle 6, and that is what we wanted to prove, and it's transitive. Let's look at the next 2. We're given angle 5 is congruent to angle 6. That's given. And I have 2 vertical angles that I'm just going to put down here. Angle 4 is congruent to angle 5, and angle 7 is congruent to angle 6, and those are because they're vertical. And now we're going to do some transitive. So I'm going to, this and this, they equal the same thing, angle 6. So I'm going to say angle 5 is congruent to angle 7. That's transitive. We want to get down to 4, so I have one last transitive. Okay, over here, I have 5 is congruent to 4, so now I'm going to go angle 4 is congruent to angle 7, and that's because it's transitive. So that concludes Unit 2.